All right, here we go. Hello, everyone. Welcome back to the stream. This is episode 3 of season 2 of building a second brain application using a bunch of technologies. And today we are going to connect Swift to Genkit. So last time around, we worked on building the RAG part of our application, and I showed you how to build a Genkit flow, and we stored our data in Cloud Firestore and wrote a trigger that whenever you write something into your database, it computes the embeddings. And then I showed you how to use those embeddings to retrieve the most matching documents. And we looked into how that looks like in Genkit. So today we are going to connect this to Swift UI and Swift/Swift UI. And it's going to be a bunch of things that we need to do to make this happen. And I'm also going to address something that someone asked on a previous stream when we talked about pricing and stuff. So we're going to do that, and no discussion about AI without using AI. So you can look forward to how I'm going to answer that question. So while we're getting ready, why don't you say hello, where you're from, and what is your favorite drink for today? So this is water. And unlike last time or the time before, I didn't eat nuts before. that was a big problem because I choked a little bit throughout the stream. That was not great. All right, so let's turn on this view. And yeah, I don't know, like I need to figure out how to best refresh the stream thing there. Anyways, so maybe a brief review of what we did last time. So here is Genkit. We've got the emulator suite running over here. So I'm running the Firebase emulator locally. So because that makes the whole experience of working with Cloud Functions a lot easier, because if you deploy a Cloud Function to the cloud, it takes a while because it needs to be compiled and provisioned, and that can take a couple of moments, and we don't want to wait that long, so we're doing everything locally. And if we make a change, we almost have a hot reloading experience, so that is really, really good. Here's our source code, and let me make sure that we have a larger space to look at. Okay, so here's our source code that we implemented last time, and this is our flow that we implemented. So here we have our semantic QA flow, and you can see that we get the user's query, and then we retrieve the matching documents from the Firestore retriever using that query. We limit the number of documents to 3. We played around with that a little bit to find out what works best, but we ended up finding out that the more data you've got in your database, the more relevant the results will probably be. And then at the end, we take that and we generate an output using our model, and we're using Gemini 1.5 Flash here. Here is our prompt, and we pass in the user's query here, and we also pass in the documents that we retrieved, and then we return the text. So we can give this a go, and why don't we use the application to generate a document. So I'm going to run the Swift application on my simulator. So we need to compile first. Here we go. Okay, so there is no data yet. Let me quickly grab this URL here and then add this to the application. So we're fetching all the Open Graph details, the title, the author, and the excerpt. And let me show you what happens when I add this. So here is our document in the database, and here are our embeddings. So every time we update this, we compute the new embeddings, and the embeddings are based on the full text. So now if we go into Genkit, we can take a look at this flow here that I showed you. Here's the semantic QA flow, and now we can ask a question. So the article that I saved was about SF symbols. So we could ask what are SF symbols? And then I can either click on run or hit Command Enter. So I'm going to hit Command Enter, and now I should get the response. And it says SF symbols are vector-based icons that offer several advantages such as scalability, multiple layers, so on and so forth. So the cool thing about Genkit is, oh, I should probably rearrange that a little bit. Okay, so the cool thing about Genkit is I can now go in and look at the trace. So in the trace, I can see what happened. So here is the entry into our flow, and we can see my input and we can see the response, but once we dig deeper, we can see what is going on. So for example, we can see how we're using the Firestore artifacts retriever. And here is the input that Genkit sends to that retriever, and you can see the text that was the user's query and the limit of please fetch only 3 documents. And here is the result. So we've got our documents, and here is one document, here is another, and here's the metadata for the document. And yeah, because we only have one document. Okay, so if we have more documents, we would see up to 3. Okay, and before we could retrieve the documents, we needed to compute the embeddings. So here you can see the embeddings that we computed for the user's query. And then using the result that we got from the retriever, we then go off and generate the response from the model. So here's our input. We specify which model to use. We provide the documents, and we tell the model that we're sending this as the user, and here's our prompt. And then at the end, we get our output. And digging even deeper, you can see that this is what the generate function sent to the model. Okay, right. And because we are currently looking at the model response, one thing that you get in the model response is some metadata about the tokens it used. So you can see here that we had 5,430 input characters, which amounts to 1,186 input tokens, and the response was worth 293 tokens. So because somebody asked, what about the cost of doing something like this? Why don't we try to find out how expensive this call was? Right? And we're going to do this using Gemini. So let's go to Gemini, and then I'm going to copy this response here, and then let's ask Gemini. I am working on an app that makes calls to an LLM, and I would, oops, sorry about that. I would like to know how expensive this is. Here is the response I got from the LLM API. Can you please analyze this and tell me how expensive this call was? Thanks. So now I'm pasting this call here, and now let's see what Gemini is able to come up with. All right, so prompt tokens, what? Okay, total tokens. Let's double check. So did it? Interesting. Usage. Oh, wow, that's pretty cool. So it even was able to figure out that the prompt had a cost or had a number of tokens. That is pretty cool. Okay, completion tokens, total tokens, which model it was used. And then, of course, it's cautious, and it says, you know, precise cost cannot be determined from the response alone, and it explains why. Missing pricing information, yeah, this is not something that we provided. Okay. And now it makes an assumption. Okay. But we want to get detailed costs. So I'm going to tell it to use the cost from the cost table on the Google page. Please use the cost information from Google's documentation to determine the exact cost for this call. Let's see. Okay, identify the pricing model. Okay. Okay, so it still goes on about hypothetical cost. So let's help a little bit. Gemini pricing. So I've tried this before. So here is the Gemini pricing page. And now we can go down and use the pay-as-you-go pricing. And then let's just use these two lines here. Please use the following information to compute the price. Okay. Okay, input costs, output costs, and the total cost per token is very small. But I was not interested in the cost per token. So what is the cost for that call I showed you in the beginning? And of course, I could use a calculator or a spreadsheet, right? But, you know, I thought it would be fun. Okay, so here we go. The estimated cost for... Was that correct? No, I think we need more guidance. Okay. Let's try again. So input pricing, output pricing, use the token count you got from the initial response. Okay, that sounds kind of reasonable. Let's see. How many calls can I make for $1? Okay, so when I did this before, it came up with a different answer. So look at that. So here we ended up. So it said, so input cost was 1,887 tokens, output tokens 370, total costs around $0.0002 and then that means we can make 5,000 calls for $1, which I think is quite affordable. So you can take that information and then determine how many users would you probably have for your application. How many of these users will use the feature to compute a summary for a text like that, and it will cost you a fraction of a cent. And then how many times would people do that, and how many users would you be able to serve with a typical usage pattern for $1? And it seems like this is certainly feasible, I think. Okay, so hopefully that gave you an idea of what the cost for an application or a feature like that might be. So recently I've started using a book tracking app for my reading, and it's called Bookshelf. And the cool thing about it is that it has a feature where you can chat with a book. So you scan the book ISBN, and then it tells you, okay, here's the cover, here's the title, and so on and so forth. And then you can start reading the book as a paper book and then track how much time you read. So, and then you can go into the chat feature and you can ask the app about the book. I don't know where they source the full text of the books, probably from the internet. So they're probably asking a regular LLM. But the cool thing about it is that you get a certain number of credits. So if you start using the application and you're using the free version of the application, you get like, I don't know, like a couple of credits so you can try the feature. And then when you buy a membership to the application or you buy a subscription, then you get a recurring number of tokens that you can use. So, and when you use up your tokens, you can go in and buy new tokens. So they basically just translate the cost that they have for running this application and using AI features to the user. And probably there is a slight markup so that they can earn some money on top, which is totally fine, I think. But I really like this idea of saying, okay, so here is a feature, we don't really know how expensive it's gonna be, and we don't want this feature to break our neck because it might get really expensive. Instead, we're charging users for using that feature in a way that is much more manageable. So I really like that. Cool. So going back to our application, let's start implementing this feature. And the first thing that we want to do is we want to turn this semantic flow here into something that we can call from outside. So what I'm going to do is I'm going to make a copy of this like this, and then I'll rename it to semantic QA flow callable. And then instead of using AI.defineFlow, I'm going to use onFlow, which is a function that we can use to expose this as a callable function to the outside world. And then we need to provide the AI parameter and apparently an auth policy. And we need to import this. And what's going on here? No. Okay. So I think that should be it. So Andre, yeah, the Firebase emulator. Didn't know it was a thing. Yeah, it's pretty cool. It's but keep in mind the Firebase emulator is an emulator, so it is close to the real thing, but not the real thing. A couple of things don't work as in the production platform, but it's, you know, it's good enough for local development, yeah, definitely something to use to speed up your development lifecycle. Great. Okay, so now we've got this semantic QA flow callable function. And now we can start looking into how to call this. And again, let's use the documentation to figure this out. So let's do Firebase call callable function from Swift. Okay, so here's the documentation. So we've done this. So we've written and deployed a callable function. We've deployed it locally. And now let's see how we can call it. So here we go, iOS. So the first thing that we need to do is import the Firebase SDK. We've already done this. We need to initialize the client SDK using functions.functions. And then we can make a call. So functions.https callable, and then you provide the name of the function, you call it, and then you pass in the parameters essentially. And you get a result and an error back, and then you can analyze if there was an error or not. You can unpack the result from the response and then do something with it. So I'll be honest, this is a part of the documentation that we probably need to update because, for one, this is still using closures, and you probably know that these days you can use async await to call stuff, which is a lot nicer to read. So that is one thing that we should probably update, and I'll take a mental note of doing that after this live stream. And the other thing is that you can also use callable to pass in your data and to read it back. And this will make all of this a lot easier, and I'm going to show you how to do this. So let's go into our front-end application, and we're first going to create a new class, and we're going to call it from template Swift file. So we're going to call it semantic QA service. Okay, great. So let's see if we can already import functions. Yes, we can. And then public class semantic QA service. And no, we want a private constructor because this is going to be a singleton. So public static let shared equals semantic QA service. Okay, so let's look at the code completion here. That actually doesn't look bad. So we define a query function. Yeah, why not? And we pass in the question, and we make this async, and it might throw. And then the response will be functions.functions.https callable semantic QA.call, and we're passing in the question like that. Yeah, I think that is okay, and it will probably work. So let's just keep this. The one thing that we need to change though is we need to use the emulator. So and again, let's try to use the documentation to find out how we can use the emulator. So here is the emulator suite documentation, connect your app and prototype. So where is the function documentation? Extensions, functions. So choose a Firebase project, Okay, so here we go. In order to connect the Firebase SDK to the Firebase emulator, we need to tell it to use emulator. So let me copy this. Let's go back into our app. And then I'm going to do this here in the initializer. We might need to tweak this a little bit, but let's try to see how this works. Okay, so I think that is what we need for this service here. And then we need to hook this up to the UI, right? So let's create a new view, new file from template, Swift UI view, and let me take a look at my notes. And we're going to call it semantic QA chat.swift. Okay. Okay, so, and we will use the typical way of structuring our code. Okay. So I've created a chat UI that we're going to use, and I'm just going to import this, or maybe I already did that. Let me double check. Package dependencies, yeah, I did. So conversation kit, that's what it's called. So we can just use that to build our view here. So we're going to wrap it in a navigation stack. And then inside conversation view, and we need to pass in a binding to messages. So we can just take a look at the source code to see how this works, right? So here in the sample application, we can see here's our conversation view. It needs to bind to a collection, to an array of messages, and then there's an on-send message callback, or actually this is a view modifier which has a callback, and whenever the user hits enter, it will be called, and then we do something with the message. Okay. So we can just take this and go back here and paste this, and then we're going to take this and put this here, and then dot init. Hello? Nope. Oh yeah, we need to import first. Import conversation kit. Okay. Let's see if this works. Content, image URL, participant. Okay. Content. Hello, my name is Sophia. What do you want to know today? We don't want to use an image URL, but the participant is going to be other. And then, yeah, we can do that. And instead of using this, we need to connect to our service. Okay, so we have our service here, and we now need to set this up in our application. So first, I'm going to define this here, and then get the chat instance. So once we've got that, we need to inject it into the environment down here, dot environment, semantic QA service, and it needs to be observable. Okay. Add observable. Nope, like this. Okay. Okay, this looks fine. And then we can close this, go back to our chat, and then pull this from the environment, add environment semantic QA service dot self var semantic QA service. Okay. And then down here we can just use it. Semantic QA service dot query, and then send the user message. So user message dot content. Oh, it might be empty. So if let query equals user message dot content, and this can throw So what we're going to do is, if it actually throws, we will try await. So let response equals, okay. And then we need to add the response of the system back into our messages collection. So let response message equals message, and the participant is other. Okay. And then messages.append response message. Cool. Okay, so here's our view. What we can do here is we can just we can append a message that is call par arrow dot localized description and then dot other. Okay, so in case you're wondering why the participant is other, the reason why is that in Conversation Kit, I'm making the assumption that you can use this to chat between a user and the system, or a user and another user. So and that is why other is always the other party, and it might even be a chat between a user and several other users, right? So, and in the typical fashion, the chat bubbles of the user will appear on one side and the chat bubbles of everybody else will appear on the other side. That is why we use other and not system. Great. Folks, feel free to use the chat. So if you've got any questions or anything is unclear, let me know. Also, let me know if you played around with Genkit between last week and this week. I'm really curious to hear what's your experience. Okay, so we've got our view. So now we need to connect it to a good place in the application. So I thought it might be cool to just add it to the main list of artifacts. So let's go back into the app to see where. So we are here in the inbox, and I want to add a button here in the toolbar so that you can tap on the button and then a sheet will appear with the chat UI. So let's do that. So we've got the toolbar here. So let's make a copy and then use bubble. And also we need a new state to track that. State private var presenting, not settings, but semantic QA dialog. And it's not presented when we start. And that's that. So when we press on this button, it will toggle, and then we need a sheet to appear. And this will be our semantic QA chat. All right. So I think that's it. Let's give it a try. All right, compiling, hydrating. How's everybody doing? Are you okay? If you've joined the stream just now, wave and say hello and tell us who you are so we know who's on the stream. All right, so configure needs to be called before using functions, right? So let's try to find out what's the problem here. Okay. Yeah, so, okay, so let's look at our initialization sequence. And it's the same problem that we already had with the authentication service, right? So you always need to call firebase app.configure first before you can make any calls to to Firebase. And that is why instead of invoking the authentication service.shared here, we declared it as an optional and then initialized it here. So I'm just going to do the same for our semantic QA service. I'm going to declare it as an optional, and then semantic QA service equals semantic QA service dot shared. And let's try this again. All right, so this worked better. And yeah, I also like the layout. So a plus button on the right, chat button on the left. So it's easy, well, for a right-handed person, it's easy to reach for the plus button. That's certainly something that, might be a preference that you might want to offer to a user. So let's add this. So we've got some data, paste, add. Let's take a look into our database. Here we are. And now let's see if this really worked. Let's try. Oh, okay. All right. Okay, let's figure out what went wrong. Stream error, inspect the details. Ooh, okay. That is interesting. You said hello. Okay, let's take a look at our... Okay, so here's the problem. Okay, so here is the problem, and let me make sure you can read it. Warning, semantic QA flow already has an index in the registry overriding. So that is, let's take a look at the source code. So I showed you that when you define a flow, you also give it a name, and this name is a string, and this is what is used to register that in the Genkit registry. So we should probably take this and update this. So let's see. Okay, so this is reloading. Let's just try again. Okay, still an internal error. But why? Okay, so in order to find out, we're going to debug. Oh, I think I know what it might be. Okay, so here's your opportunity to participate. What do you think is the problem? Why is there an internal error? Why can't we call into our backend? So it is probably not that stream error here, because that relates to Firestore, and that is something that we need to look in later. But it is something else. And to give you a hint, I'm going to show you the log output here. So look at this. So when the emulator starts up, this more readable. Okay, when the emulator starts up, it tells you where your functions are running. And the interesting thing here is that, of course, it's running on localhost, and here is the port, and then it uses your project name, and here is the interesting part. It also uses the region as part of the URL, and the region here is US Central 1, and then you've got the name of the function, which here in our case is semantic QA flow callable. So what I think is that we might not be using the correct URL. Let's find out. So our service is here, and I think we need to provide the region. US Central 1. Okay. Oh, no. US. So let's run this again. Here is our inbox, and let's just send a chat message. Oh, still. Okay, so now this one is saying, did I, yeah, I'm using the emulators. So we're using the emulator for Firestore, for auth, and what we should also be doing. So let's go to our Firestore service. There is another thing, but first let's clean up the code, because that is also something that we should be doing. Okay. Here is our QA service. So what I did on user defaults, I implemented this extension, and what it does, it reads from the application's launch arguments and reads the use emulator launch argument, and then tries to figure out if this is true or false, and then returns that value as a bool. So let's do that for Firebase functions. So the other thing that might be the problem is we are not authenticated. So let's take a look here. So we are not signed in here, so there is no user. And that is something that you need to do before you can use Cloud Functions. So this said the user was signed in, but that was from a previous session probably, and from a previous, I don't know, from a previous run instance. And the problem here is, so if you remember, I think 2 or 3 times ago when we talked about Firebase authentication, I said that Firebase authentication, if you implement it correctly, will keep the authentication state in your iOS keychain. And that is what happened here, right? So we've got our authentication token for that test@test.com user, and it was stored in the keychain, but it was from an emulator run instance that is no longer that no longer exists, right? Because I probably did this while I was testing earlier today, but I killed that emulator instance. And even during this live stream, I restarted the emulator multiple times. So that means that it loses that user identity. So the token that is stored in our keychain is no longer valid because it belongs to a user that no longer exists. Anyways, so let's create a new user test at test.com, tests 1, 2, 3, 4, and we actually need to sign up. Tests 1, 2, 3, 4, sign up. Okay, let's take a look. Here is our user. Let's go back into the app. Let's make a call. Not found. Okay, that is new. but our call at least made it through. Let's see. Okay, and here we go. So that is the wrong name. Because we trusted code completion. Okay, let's use the correct name. So the correct name for calling a callable function is not this one, because that is the one that is being used to register the function in the Genkit registry, but this one is the one that we need to use. Let's go back. Let's paste this here. And then while we're at it, yeah, let's see. Okay, so running this again. And where is my emulator? Okay, so this looks much better. Internal, okay. Now let's take a look at our console to see what's the problem. So it seemed like it did execute this, but it also seems like there might be a problem. And I think I might have an idea of what it is. So we get the query, and I think what we need to do is we need to const yeah, maybe we need to do that like this. No. Oh yeah, so oh, that's okay, so let's go back. So what we're doing is we're sending this parameter, and it's called question. So we now need to tell Genkit about this, and we can probably do this by using this input schema. So instead of doing z.string, let's try z.object, and then I think it was question, right? Yeah. Question z.string. Okay. And then const question equals query, and then we want to use it. Oops. Nope. And then we want to, yeah. Comma, and then down here. Okay, let's give this a try. All right, here we go. So please provide the context you'd like me to use to answer your question about AAA. I need that information to give you a relevant and accurate response. Hello. Okay, so Let's look at what did happen by looking into the Genkit traces. So you can see that 857, that is the most recent call. You can see all the errors here as well. So let's take a look at the errors. And we should have done this in the first place, right? Because here it says schema validation failed, parse errors, query must have required property content, provided data was, and then you can look at that. So query was provided, and then inside there is question, right? And then we've got hello. So, and here the question is hello, please provide the context. And we probably weren't able to find any artifacts in the database. See, there are no documents because probably the database is empty. Let's take a look at Firestore. Yes, it's empty. So let's first add something into the database, creating custom SS symbols, add this here, paste, add. Let's verify it's made it into. What is happening? All right. It would have been too easy, I think. Okay, let's delete this again. Let's sign out. Let's look at authentication. Let's sign in again. Tests at test.com. Sign in. Add this to the database. Here we go. What? Yeah. Okay, so there it is. And now let's go back into the app, ask a question. What are SF symbols? SF symbols are vector-based icons provided by Apple. Tell me how I can create new SF symbols. And here you go. To create SF symbols without design software, use the SF symbols app. And this is exactly what is explained in that article. So one more, tell me how to create SF symbols, but answer in rhyme form. To craft a symbol, SF's way to go. No design skills needed. Watch your progress grow. First find a base, a symbol you adore, then duplicate as custom and ask for more. Next, combine symbol, a menu you'll see with enclosures, badges, and a slash to be free. Choose your adornments, adjust with a flair, position, offset with meticulous care. Really nice. Let's look at how this looks in Genkit, because if you remember what we did last time, I connected Genkit to my emulator instance so that we can actually see what is going on. So let's click on traces here. Here's our trace. It was a success, and we can look into it and make a little bit more space. So here is my question. Here is the output. And we can see how it retrieved the documents, how it used the embedder to compute the embeddings for my query, and then how the generate method did make a call to the model and came up with the response. Cool. So one final thing before we can do some Q&A on the chat is let's try to see what happens when I actually want to refer back to something that I said earlier, right? So so we've been talking about SS symbols, and then now let's say something like, what if I want to, or can I export them as a PNG file? So now it will probably say, I have no idea. The provided text explains how to export a custom SS symbol. Okay, so so what I was trying to get at, I wanted to refer back to something that happened earlier in the chat. So maybe we can try to refer back to the poem. What did you think about that poem? Okay, so now it doesn't know what about the poem because that is not in the context. And if we look at this latest trace here, this one, what did you think about that poem? This prompt here will now be taken. So we're trying to get the document. So we actually get this one document because it's the only document that we have in a database. But then once we send this to the model, tell me what I need to know about what did you think about that poem, there is nothing except for the document that tells the model what we're referring to. So in order to solve that, we need to provide more context and we need to send in the entire chat history. And that's not something that we're doing at the moment. So that's what we're going to do next time. And maybe a couple of other things that we can look into. But for today, I want to open it for Q&A. So if you've got any questions that you want to ask, feel free to fire away in the live chat. And I'm happy to answer. Or you can just try out tapping on one of the emojis. For example, this one. All right. I'll give it a minute, and if nobody has any questions, we can call it a day. Oh, while I wait for people to maybe have questions, I'll show you one more thing that I think I should have done earlier on. So, Command B. Okay. So whenever we started the emulator, the problem was that the data was not persisted. So let's try and fix that. So in this IDE, I've got cursor. So let's just tell it to enhance this. Can you please make sure that the emulator persists any data when shutting down and reloads it when booting up. Here we go. So it suggests adding a couple of command line flags, -- import and -- export on exit. So I think that is correct. So let's apply this. And let's take a look. So import, and then you specify the folder where you want to import from, and export on exit. That looks correct. And of course, we need to, did it already restart? Okay, let's go back to our IDE and see if that worked. Not sure. Let me look into, no, it did not. So let's shut this down and then launch again. Yeah, because how should it know about it, right? Because this is an entirely different command line. Okay, so obviously now this is empty because, and also the user has gone away. So let's just log out, log in again, sign up, test at test.com, tests. Sign up. Okay. Here is the user ID 9C, blah, blah, blah. And now I'm going to shut down the emulator. Okay, this seems to have worked. We've got emulator data now. And when we start this again, it should reread the data. Here we are. Not yet. Still booting. And here we go. It's got the user. And now if I add something to the database, bam, like this, it will be in a database. And let's terminate once more and boot up once more. We should be able to see the data that we stored in the previous session. Here we go. So that is also quite useful for working locally because, let's be honest, it was kind of cumbersome to have to log in and log out, or log out, log in again all of the time, because there is just you know, a step too much, I think. All right, so we've got a question. Not sure if I understand the pricing correctly. If the database contains many documents against which the query runs, are more tokens involved and the query becomes more expensive? So yes and no. So this depends on how many documents you retrieve from the database, right? So actually let's simulate this. So let's add another article. So this is about Swift, and then let's find, is there a related one? Optionals. Let's add this one as well. And maybe another one. JSON parsing, enums, type throws. Okay, so we've got 4 documents in here. And then maybe hiking in Scotland. Why not? So something completely unrelated, yeah? That is the reason why I'm adding this. Okay. Here are all the documents, and we've got all the embeddings for them. So now if we go in and use our flow, what's happening here? Okay, that is not great. Okay, that is why. So one of our embedders, or the embedder, doesn't work for documents that are very long. And that means that not all of the documents have embeddings. Let's take a look. So this one doesn't have, so Explores Kotlin unfortunately doesn't have embeddings. Optionals doesn't have embeddings. Enums doesn't have embeddings. That is not great. Okay, so I'm going to delete the ones that don't have embeddings. So, and this is something that we need to fix next time, right? So we need to use an embedder that can deal with larger documents. Okay, so maybe we can find something here that is unrelated. Yeah, maybe this. 17 minutes read, that is too long. 9 minutes. Might be okay. Oh. Is this still running? No, it's not. Okay, so while this is booting up, I can already fetch this stuff and then add this. Okay, so are we back in business? Yes, we are. Okay. Oh no, this is too long. I'm so sorry about this. Anyways, I think it should still work. So let's just boot this again. And then I'm just going to show you with the 2 documents that we have. Yeah, Carter, you're absolutely right. I should probably just log and not crash. Definitely. But I first want to answer Lars's question. So let's go to our flow and let's go to the semantic QA flow. And so the one of the documents is, so this one has embeddings. It is about SF symbols. This other one also has embeddings. It is about type throws. And this one here does not have embeddings. So let's delete it. Okay, so teach me what's happening here. Come on. All right. So we just need to make sure that Genkit is actually running. So it needs to connect to the emulator any moment. So teach me about typed rows in Swift. So this will return up to 3 documents, or yeah. So now it explains how type throws works, and let's look at the trace to see what happened. So we first retrieve the documents, and here is where it's where the interesting part is, right? So we compute the embeddings for teach me how type throws in Swift works, and we've got the embeddings for that. We go to the artifact retriever to retrieve all matching documents, and we tell it, up to 3 documents, please. So let's expand this. So we get this first document here, and it is the one from Antoine from Swiftly. So this is the one about type throws. This is the most similar one to my query, actually about type throws. So let's see if we get another document. Yeah, so this next one here is about SF symbols. So this is not related to type throws, but we told the retriever to retrieve up to 3 documents. So it's trying to get the most similar documents. And the one about SF symbols is not very similar. In fact, it's probably quite unsimilar, but it's not, it is still kind of similar. It's more similar than nothing. That's why it returns that document as well. So we're now getting those 2 documents. Okay, so, and now we're passing it to the generate function. So both documents will be in here. Let's see, where's the input? Oh, no, that's the response. Sorry, we need to look at the input. So here is the first document, and that's the one from about type throws. And then we should see the second document, which is about SF symbols. So let's wait. Here we go. So we're passing this one in as well. So now let's look at the output we get from the model. And the model now tells us, okay, so here is all the tokens that you used. So input characters, 12,000 something. That is a lot more than the ones that we sent in when we only sent 1 document in. It also means that the input tokens are much larger, or are a lot more. And the number of total tokens also is a lot higher. So that means this call is more expensive. What does that mean? It means that first you should play around with the limit. So now the current state of the database is not representative. Usually you would probably have a lot more documents in the database, not just those 2. And those documents have a much broader variety, and you would probably have a lot more documents in there that are about one topic, right? So I would, in the real world, I would have a lot of articles in there that talk about Swift. So whenever I ask something that is related to Swift, the documents that come back are related to Swift. And that will improve the answer that the model will give. So that is one thing. Play around with the limit. The other thing is, and we talked about this last time, and you already saw this in the console output, what we're currently doing is we take the entire document. So we take the entire blog post and embed the entire thing. And that means that when we retrieve the embeddings from the database, we will also get the entire document back. Whereas it might probably not be best to get the entire document back because, if you, for example, if you look at a regular article, and let's use this one, type throws. So it talks about a lot of things, but not all of those things are relevant to my question, right? Or let's go back and look at this one here. So let's go into this article about SF symbols. So this talks about a lot of things about SF symbols, but if I specifically ask, how can I create SF symbols, then, this paragraph here is not relevant. And this one is also not relevant, and this one is also not relevant. But, this part here starts to begin relevant, right? So when we chunk our documents into smaller pieces and we, for example, we chunk them, just let's imagine we would chunk those documents by paragraphs. So this would be a chunk, this would be a chunk, this would be a chunk, and then we'd compute embeddings per paragraph, we would get a much more finely granular answer back. So if I ask something about how can I create SS symbols, it would go in and then it will say, all right, so this here might be relevant, and this here might be relevant, and this here might be relevant, but everything at the top might not be relevant. So I get, all those paragraphs, and then I could probably say, well, give me up to 5 or 7 documents back, but the documents are no longer the entire text of the blog post, but all those tiny little pieces. So what you get back is a much more focused thing, and that will be 1, more focused, 2, a lot less text, and that means your call will be a lot cheaper, right? So instead of sending in 12,000 characters, which might be way too much, it will just be maybe 3,000 characters. And let's imagine that in addition to maybe blog posts, you might also have entire PDF files in there. Let's imagine that you upload a PDF file of the Swift language guide into the database. So that is a document that has several hundred pages. And if we use a naive approach like we've currently implemented, that would be very inefficient and very expensive, because you'd send the entire document, which has probably many 10,000s of tokens, and each turnaround or cycle would be very expensive for you. So definitely something that we need to optimize, and that we can look into next time, for sure. Great question, Lars. All right. Thanks, Lars. I'm glad it was a good explanation. So, unless anybody has another question, I think we can call it a day. Thanks everybody for tuning in. I am looking forward to seeing you again, but probably not next week, because I need to go to London to record a couple of videos, and I will not be able to stream from the studio. It's quite complicated, but I will be back the week after. Watch out on social media. I'll post when exactly we're gonna go live again. Probably the same time on a Tuesday, but I'll post beforehand. All right. Thanks for tuning in, everybody. It was great fun. I hope you learned something and you were inspired. Have a great rest of your day wherever you are on the planet. Bye.